Hey everyone, welcome to The Explainer. Today we're diving straight into the chapter, Grandmother's Quilt, Borders, and the Inside Scoop. We're going to take what looks like an everyday, simple crafting project and turn it into a total masterclass on how we measure the space around us. We're unlocking the secrets of shapes, boundaries, the whole shebang. Let's get right into it.
Imagine you've just stitched together this beautiful, cozy quilt out of old clothes, right? And you want to give it that absolute perfect finishing touch, a gorgeous lace border wrapped all the way around the edge. But here's the million-dollar question. How do you know exactly how much lace to buy? I mean, if you just kind of eyeball it and guess, you might end up way short. Or, you might waste your hard-earned money buying way too much. We need a system here.
To solve this little mystery, we need to bring in our lead detectives for this chapter, Preetha, Audrit, and their grandmother. Picture them sitting together, hard at work on this stunning yellow and red checkerboard quilt. Grandmother wants to decorate it with that lace we just talked about, but to do it accurately, without guessing, well, she first needs to teach Preetha and Audrit our very first major concept of the explainer.
And that concept is perimeter. Simply put, perimeter is just the total length of the border of a shape. Think of it like the outline. Like if you were a tiny little ant walking exactly along the very outer edge of that quilt until you got all the way back to where you started, the total distance you walked, that's the perimeter. It's the decorative lace wrapping right around the outside.
So, let's actually see how this plays out in the real world. Grandmother decides she's going to use some vibrant red lace for one of her projects. By carefully measuring and adding up the lengths of all the outer sides of her shape, she calculates that she needs exactly 40 units of red lace. Boom! No guessing, no estimating, just pure, precise border measurement. That, my friends, is the magic of understanding perimeter.
All right, so we've totally mastered the outside edge. But what about the inside? Well, our detectives Preetha and Audrit decide to take a quick break from the quilt to look at a completely different problem, covering the flat surface of their wooden table.
Now think about this for a second. If you had a bunch of identical shapes and you wanted to lay them down completely flat to cover a table, meaning absolutely no overlaps and no empty spaces peeking through, what shapes would actually work? Like, what happens if you try to use circles? Do circles tile?
Well, this beautifully illustrates exactly what happens. On the left, Preetha tried covering a table with triangles. And notice how they just interlock perfectly? They slide right up against each other, completely covering that surface. But then look at the table on the right with the circles. No matter how tightly you try to pack those things together, they always leave these awkward little star-shaped gaps in between. So yeah, circles, they are absolutely terrible for measuring flat space, simply because they just do not tile. But then, Audrit tries squares. And wow, look at how beautifully organized that is. Squares are literally the ultimate shape for covering a region. They've got straight edges, equal sides, right angles, which means they line up back to back, side to side completely seamlessly. Zero gaps, zero overlaps. And that makes them the absolute perfect tool for our next big concept.
Which brings us right to our definition of area. Remember how perimeter is the outside border? Well, area is the entire region covered by a shape. It's the inside space. And because those squares tile so flawlessly, we actually measure area by counting how many of these standardized squares fit inside our shape. We literally call these square units. It's so neat how that works out.
Honestly, putting objects onto a square grid is an absolute life hack. Take a look at these three rectangles. The yellow one is A, pink is B, and the purple one is C. If I just asked you right now which one is the biggest, it might be kind of tough to tell just by glancing at them, right? But on this grid, we just count the squares. Rectangle A covers 12 squares. B covers 8. C covers 10. Boom. Instantly, we know A has the largest area. It is just so visually satisfying.
But hold on, we run into a little problem here. Counting squares works great for a small drawing, sure, but what if grandmother is making a massive, room-sized rug out of square patches? Are we seriously going to get down on our hands and knees and count 1, 2, 3, all the way up to hundreds of patches? No way. That would take forever.
Luckily, mathematics is all about finding elegant shortcuts. We absolutely do not have to count every single square. We have a cheat code. Step 1. Just count how many rows of patches there are. Step 2. Count how many patches are in just one single column. And step 3. Simply multiply those two numbers together. Boom! 24. Let's say Grandma's rug has 6 rows, and each row has 4 patches. Instead of counting every single one individually, we just do 6 times 4. And instantly, we get 24 square patches. It's a massive time saver, and I just love how it beautifully connects the geometry of physical space straight into the arithmetic of multiplication. And this, of course, brings us to our official area formula as outlined in the chapter. The area of a rectangle equals length multiplied by breadth. Now, this isn't just some random rule you have to memorize. As we just saw with the patches, it perfectly describes the row and column reality of a grid. So, if the length is 6 centimeters and the breadth is 4 centimeters, the area is simply 24 square centimeters. Makes perfect sense, right?
Okay, but what if we want to put lace around that exact same 6x4 rug? Well, we need the perimeter shortcut. Keep in mind, a rectangle always has 2 equal lengths and 2 equal breadths. So instead of going the long way and adding length plus breadth, we just multiply. It's 2 times the length plus 2 times the breadth. Fast, reliable, and it guarantees we buy the exact right amount of lace at the store.
Look, if you remember absolutely nothing else from today's explainer, please make it this. Perimeter is the border, it's the lace, and it's measured in normal units, like centimeters. Area, on the other hand, is the inside, it's the patches, and it's measured in square units. Lace versus patches, outside versus inside. Lock that anchor into your mind, and I promise you will never confuse the two again.
All right, now that we are all total experts on this, it's time to actually put it to the test with a really brilliant game from our source material. This is where things get fun, because we actually get to play with space and see exactly how area and perimeter interact in real time. So here's how you play the perimeter game. First, you roll a die. Whatever number you get, you pick up exactly that many square tiles. You arrange them flat on the table, making sure they touch edge to edge. Then, the next player rolls and adds their tiles to that exact same shape, so its area is constantly growing. But here's the catch. The goal isn't area. The winner is the person who places a tile that makes the outside border, the perimeter, hit exactly 24. It is such an incredibly clever way to realize that a shape can completely change its outside border depending entirely on how you arrange its inside space.
Now, before we wrap up, I want to leave you with a little challenge. Look directly at the screen you're using to watch this right now. Could be your phone, your tablet, your monitor. Run your eyes along its outside edge. That right there, that's its perimeter. Now look at the glowing pixels covering the screen itself. That is the area. How many square centimeters do you think are glowing at you right at this very second? Mathematics isn't just stuck in textbooks, guys. It is literally the structure of the world all around us. So grab a ruler, measure the length and breadth of your device, and calculate it for yourself. Thanks so much for hanging out with me on this explainer, and keep exploring.